Yeah, shall I start? David,
Yes,
sir?
sir.
Yes, sir. Thank you. So, is it visible? My presentation is visible.
Visible, sir.
Yes, sir.
Yeah, okay. Once again, good evening. Today we would like to discuss about how can we build an intelligence system? How can we take a decision in real-time applications? Before going to the decision making, first of all, how can we build a good intelligence system? So the intelligence system, it means it is a computer system. Generally, it is a computer system that can perceive something from the environment by using many sensors. So that is act like as a human. We know this is a basic definition of the artificial intelligence. At the same time, in this intelligent system, we can go with big data as well as artificial intelligence. Generally, this is designed to simulate intelligent behavior of artificial intelligence. So how can we learn? How can we experience? And how can we adapt our situations? Then we can go with expert systems. Generally, the basic definition for intelligence system is how can we make a decision or how can we take a decision autonomously? So voluntarily, how can we take a decision? So that is the main motto of intelligence system. So based upon this intelligence system, we can add many techniques. The first one is artificial intelligence. Next one is the big data. These are the two combination of advanced fields as per the intelligence system. One side, A is supporting to all the machine learning, deep learning techniques, as well as big data is supporting to all the analytics. So we can start from our database management system, data warehouse, and big data, and the data analytics and data science. And the final one is cloud computing and geographic information system. So we know up to only big data and data science and data analytics, but we don't know and we don't want to familiar with geographic information system. So that geographic information system fully based upon spatial information. Spatial means we know in our intelligence system, we can classify as two. One is spatial, second one is the non-spatial. So spatial means it has latitude, longitude, and altitude. So in generally mathematics, we can go with X coordinate, Y coordinate, and Z coordinate. So here, as per the spatial technology, that is treated as latitude, longitude, and altitude, X coordinate, Y coordinate, and Z coordinate. Based upon all these three, we can find out the location of a person, location of an object, location of the real world thing. So that is the impact of GIS. So that's why here we can introduce a remote sensing geographic information system that is treated as spatial remote sensing or spatial intelligence. So up to now, we know only big data with AI. Now, I would like to introduce how can we take advanced technologies of remote sensing, GPS, that means global positioning system, and GIS in intelligence systems. Here, this is the sensors combination. We know. So I would like to gather some information from the environment. How can we gather the information? Generally, we can gather information from our eyes, ears, tongue. So these are the sensors. Same as per the intelligence system, we can deploy many sensors over the world, over the environment. So based upon the sensors, the brain will identify, the brain will perceive what is the input from our big data. What's the input from our sensor? What is the input from our basic needs? After sensing of some information, then we can go with data processing unit. So in this data processing unit, the first one, we had to introduce algorithms, either machine learning algorithms, deep learning algorithms, or the transfer learning algorithms. Finally, machine learning, deep learning, transfer learning, these are the part and parcel of artificial intelligence. So we can combine artificial intelligence as well as data analytics or the big data. We can derive or we can define a perfect intelligence system where we have to move from sensing agents to activators. We know the activators, hands, legs, these are the activators. So this is the aspect of the human body. So as for the activators of Tesla, self-driving cars are there. So Sophia is there, it's a robot. So it has a citizenship. So that will think like human, that will act like human. So that is the activator. After completion of sensing, after completion of the algorithm, then we can go with feedback mechanism. The feedback mechanism will take the decision. Yeah, this is the right answer. This is the wrong answer. Based upon your input, based upon your algorithm, based upon your activation function of the activator, then we can take the feedback. How can we take the feedback here? I would like to go with 100%. 100% target is there, or 100% threshold is there. 99.99, that is not accurate. Of course, it will reach 0.0 something, or 1 is there. A small gap is there. But the feedback must hold an important role in the intelligence system. Artificial intelligence systems only building up some networks, some issues, some algorithms of some problems. But an intelligent system must host a perfect threshold, a perfect robotic threshold of any mission. So this is a brief introduction about an intelligence system. Generally, big data refers to vast amounts of the data. So maybe here we can go with structured data, unstructured data. So we can collect some information, then we can analyze. Then after the analyzing, what we do here, we can take a perfect decision. How can we take the decision? Before going to the decision, you should concentrate on big data dimensions of the big data, because it has large volumes of the data set. The huge volumes of the data sets are there. The data set, the data cube, or the data cuboid, we don't know exactly, but we have to measure volume, velocity, variety, and value. So these are the different characteristics of big data. Here in these concepts, one is there. So one that is dealing about the big data, that is extremely dedicated to large amount of the data or huge amount of the data. So here in this association, what we identify here, one data is spatial, one is the non-spatial. Then we can combine spatial data with the non-spatial data. So as per the DBMS, we can go with the non-spatial data. As per the GIS, Geographic Information System, we can go with spatial data. So that's why nowadays we're using Zomato. So in the Zomato, the Uber, what we use here, latitude, longitude, altitude. So this is same as, this is the same structure for objects in the Mars. So objects in the other planets. Okay, nowadays we are using and we are doing research on aliens. Alien technology is there. Nowadays that is called as artificial intelligence technology or the alien technology. So in that alien technology, what they use here, geographic information system. Right? So here we can find out some of the objects from the Mars or some other planets. So at the same time, we can go with real-time applications with different patterns. Pattern is the very, very important thing here. What's a pattern here? A pattern means, so maybe it's the structured data, the unstructured data. Therefore, in this big data analysis, what we analyze here, structured or the unstructured data. At the same time, coming to the point number 2, artificial intelligence. In this artificial intelligence, so generally this system is meant for computer system. At the same time, we can incorporate human intelligence as artificial intelligence here, such as we can solve the problems, we can take the decisions, and we can go with many solutions. Okay, right? So the solutions may be generative, or is a general, or the strong, or something. Coming to the third one here was a relationship between big data and the artificial intelligence here. So generally, so as for the decision making, we can go. The first one is data analysis. Based upon the data analysis, we can take the decision. It's the first one. Second one, artificial intelligence that holds how can we think, how can we generate a solution for the problem. So based upon these two, we can go with predictive maintenance and the predictive analysis here. Right? Where these are the different data sources. Generally, I would like to go with the text data or the text mining. Otherwise, we can go with audio mining, video mining, or some image minings are there. So that's why we can use different types of the data. Reuters is the database, 21758. So text files are there. So that was structured data, WebKB. So this is the another data source. So Mendeley, this is the another data source. So Kaggle, this is the another data source. These are all the structure. Structure means organized. It's a well organized. So generally that was treated as schemas. Second one is the unstructured data. So whereas in this unstructured data, we have to concentrate on dimensions of the database or the dimensions of the data cuboid. Here, the second picture indicates cloud is there and different servers are there. That indicates what is multimedia or the multi-dimensional data is there. That was unstructured data. Structure must holds a perfect organization is there. It's a perfect schema structure is there. In this unstructured data, maybe miscellaneous data is there. Patterns are invisible. So volumes are invisible. So then we have to classify the data. So that's why what we know, the integration of the big data and the AI. So you have to concentrate on different learning techniques. Machine learning, different learning techniques are there. Deep learning, different learning techniques are there. Transfer learning, different learning techniques are there. So, but here we can integrate big data and AI here. So this is the data ingestion. In this data ingestion, we can go with many applications. Many applications, just like predictive maintenance is the first application. Personalized recommendations is the next application here. We can go with the image classification, image segmentation, so speech recognition, so healthcare analytics, autonomous vehicles. So these are the different aspects for data ingestion. Coming to the second one, AI model training. In this AI model training, we have to train the system. How can we train the system? Just like our computer. Our computer has C drive, D drive, E drive, and F drive. So that was trained. All system softwares are dedicated to C drive. D drive that indicates we can go with some important files. E drive, that is the entertainment. F drive means some personal files are there. That was trained. Same thing here, AI model trained. So that consisting of some space is there. So what's the space here? We can take the GB, gigabyte, or the megabyte, or the terabyte. So that indicates how many images are there. What's the range of the image? That was trained. Coming to the next one, real-time analytics are there. So in this real-time analytics, how can we take the decision? Suppose some earthquakes are there, some cyclones are there, some fires are there, some floods are there. How can we take the decision immediately? Based upon your sensing range, based upon your sensor input, based upon your sensor output. So how neural network will work on? So that is a real-time analytics. Okay, next one here. These are the different types of integration systems or intelligence systems. Intelligence systems that was internally integrated. So not only dedicated to AI, not only dedicated to the big data, not only dedicated to some other language. So that is the integrated system. Intelligence system is the integrated system. So in this integrated system, the first type is a rule-based system. what do you mean by rule-based here? So this rule-based means purely dedicated to the decisions. How can we take the decision? Rules. So in SQL, we can go select start from something. It's a rule. We have to take the condition. Based upon that condition, we can get the output here. Same thing in this artificial intelligence, what we use here, predefined rules are there. Predefined regions are there. Based upon that regions, those are considered as if-then statements are. Coming to the next one, machine learning systems. In this machine learning systems, first of all, you should know, or we should know, what is the knowledge base here? What's the minimum knowledge base? After the minimum knowledge base, then we can go with expert systems. So in these expert systems, the first one is inference engine. Okay, let's consider here diagram is there, some picture is there. The middle one is intelligence system or integrated system. So in this intelligence system, we have many applications surrounding. Okay, one is the education, one is the healthcare system, one is the neural network system, one is the sensor system, one is a robotic system, one is textile system. So these are the different systems. So here, how many algorithms we can use here? Many algorithms based upon the user requirements, based upon the user needs. But here, where is the expert system? The expert system must hold highest accuracy, perfect decision making. So these two values are important for expert system. Coming to the fourth one, neural network. We know the neural network. In the neural network, so how many neurons are there? How many inputs are there? How many hidden layers are there? Then how can we use some bias? How can we take sigmoid function or the ReLU function? Then how can we build a perfect answer? So these are the different types of intelligence systems. So these are the challenges. So what's the first challenge here? Integration. Intelligence system means it's the integration. How can we integrate big data with artificial intelligence? Big data with the cloud computing. So big data with the machine learning, big data with the remote sensing, big data with the geographic information system, big data with the global positioning system. How can we integrate? It's the biggest challenge here. So this is the first one. Second one, algorithm. Only we have to concentrate on algorithm only, right? So the algorithm must force many decisions are there, many inputs are there, many functions are there. So that is the user requirement. Coming to the third one, resource management. So in this resource management, we should concentrate on rule matching. What's the rule here? What is our target data? What is our trained data? Target data is already predefined. At the same time, trained data predefined. So based upon this target and train, we can take rule matching here. So that indicates inference engine matches facts about what's the knowledge base and what is the application. So if it is failure, then rule firing is there. What do you mean by rule firing here? The rule firing must hold recommendation systems. In this recommendation systems, so this rule is perfect for this threshold. This rule is good for this threshold or the output. So that rule firing must hold. This is the recommendation for this algorithm. That was the resource management for effective analysis. So in this analysis, artificial intelligence and machine learning analysis, mainly we can go with three types of learnings. We know supervised, unsupervised, and the reinforcement learning. So coming to the first one, what do you mean by supervisor learning here? So supervisor learning, generally, we know already, I think last few days, you heard about supervisor learning, unsupervised learning, reinforcement learning, but I don't want to concentrate on deeply, but brief introduction I will give. What do you mean by supervisor? A supervisor is there, a guide is there. So that's why it's the supervisor learning here. But unsupervised, the best example, we will take classification, unsupervised. So is it labeled data, unlabeled data? We have to concentrate on. So coming to the reinforcement learning, generally that was the unlabeled. Reinforcement learning, we can combine. So what's the capacity? What's the capacity of the image classification? How can we combine NLPs? How can we take the overfitting? How can we take the high accuracy? How it will work on regression analysis? These are all considerations of the reinforcement learning. So generally, either supervised learning or unsupervised learning, what we use here, we can go with pre-processing of the data. Then we can go with the process of the stemming of the stopwatch. Then we can go with the clustering, classification, regression analysis, and so on. But finally, reinforcement learning must taking up the decision of what is. So purely that was high accuracy. Not only the high accuracy, it has labeling requirements. So it will handle overfitting also. This is the consideration about reinforcement learning. Coming to the applications of intelligence system, the first one, healthcare. Generally, healthcare, we can go with the cancer, heart attacks, or different healthcare system problems are there. In that, we can go with diabetic retinopathy, glaucoma. So these are the different blindness. The basic reasons for diabetic retinopathy and glaucoma, we can recognize different cotton wools in our iris. Clotted blood are the cotton wools. So when you are identifying cotton wools or clots in our iris, so maybe within 1 year or within 6 months or within 1 month, they will get blind. So such type of diagnosis must hold in artificial intelligence. So that's why healthcare is the very, very important aspect in the intelligence system. Second one, finance. Nowadays, we are using fraud detections, cryptography, blockchaining, security, stock market analysis, risk analysis. Is a finance. Then next one is the manufacturing. So nowadays, we are using different manufacturing units. How can we manufacture a perfect robot? How can we manufacture a perfect mission? How can we manufacture a smart robot? So that robot must hold a perfect intelligence of integration system. Coming to the transportation, nowadays we are using Tesla cars, self-driving cars, and then smart traffic management system is there. In this smart traffic management system, for sure, we should apply GPS and GIS, global positioning system and GIS. So that's why we need what's the source and what's the destination. In between, we can identify what's the traffic. This is the transportation. So the traffic is real-time traffic. Coming to the next one, home. Nowadays, we're using home devices. So these are the different applications for intelligence system. Now, this is the precision agriculture. So as for the precision agriculture, the first one, connected livestock is there. So here we can deploy, maybe is the field of the paddy or the wheat or something. So what we do here, we have to deploy sensors. We can use the sensors in many areas, then that will send something. Based upon that information, we can analyze the data through big data or the data analysis. Okay, right? Maybe this is the low level data or the middle level or the high level. We can categorize the data. After the categorize the data, then what we do here, we can use some techniques. Maybe reinforcement learning, maybe supervised, maybe unsupervised, something. So this is the precision agriculture picture where smart drones are there. Nowadays, we are using for good crop yield protection. How can we take good crop yield protection here? How can we detect this leaf is some disease? this leaf, some wheat or the paddy, it has some disease. How can we identify? To the drone remote sensing. Nowadays, we are using remote sensing as drone remote sensing. So we can go with different types of remote sensing. The first one, drone remote sensing. Next one, satellite remote sensing. And what's the difference between drone and the satellite here? Drone remote sensing, it will fly up to 5 kilometers at the 10 kilometers range. Whereas satellite remote sensing, we can deploy minimum satellites are 24 satellites around the earth. Continuously, they will monitor, those systems will monitor. So what is going on? What is going on the earth, in ocean, so and so on. So these smart drones are applicable for exact precision agriculture or accurate precision agriculture. Coming to the third one, autonomous tractors are there. The tractor is nothing but smart robot. Generally, that will use for reducing of labor, reducing of fuel, and reducing of the soil erosion. Coming to the next one, weather forecasting is there. Now, in this session, I would like to concentrate on weather. So I will explain within 5 to 10 minutes, what are the real world applications for weather forecasting? How can we go with different sensors? How can we collect the data? How can we analyze the data? How can we send the information? Then how can we take the decision? So in these 6 or 7, I would like to concentrate on weather forecasting. Coming to the next one, soil sensors are there. Where in the soil sensor, the first one is, which type of soil is there? Is it red soil, or the mud soil, or the black soil? That is the categorization of the soil. The intelligent system or the integrated system will take the decision. This soil is suitable for this crop. Okay, nowadays, illiterates are there, farmers are there. They don't know what are the minerals of the soil. What's the strength of the soil? They don't know. So, as per computer expert or the intelligent expert, you have to gather some soil from the farmer. Then you have to put it on the desk. Then you can take the picture. Then that will give to some accurate sensor. That sensor will identify what are the minerals of the soil. What's the yield rate of the soil? Is it dead level or live level? That will tell. That sensor will tell. The soil sensor will tell. So what are the yield rate of next 2 years, next decade? Based upon that information, the farmer will take the decision. I'm repeating once again here. This soil sensor is applicable for what's the strength of the soil. Not only the strength of the soil, that will take the decision. Okay, this crop is suitable for this soil. This red soil must host this crop. This paddy must host this crop. This soil must host such type of irrigation. Coming to the next one, agribores. We know the agribores. Nowadays we are using some fertilizers. We can reduce the fertilizer capacity up to 90%. How? Based upon these robots. Next one, farming data. After completion of all the sensing information, we can take the decision through the farming. Yeah, this is the architecture of intelligence system. So in this architecture, the first one is a human brain, just like the human brain. Human will think like that one. The first one, sensing some information from other sensors. Then computer vision is there. So these are the 8 technologies, artificial intelligence technologies, right side. So audio processing is there. Sensing has 2 categories. The first one, computer vision, where we can use different images. Based upon that image features, we can finalize this is the solution. This is the accurate information. This is the abundant information. This is the miscellaneous information. We can easily find out. As for the audio processing, so this is applicable for illiterates, not only illiterates. We can add background audio for sensing some information. The sensor will act based upon your audio. Coming to the next one, comprehend, where what we use here, NLP, natural language processing, and the knowledge representation. Here in this NLP, the system will recognize your mother tongue. Based upon that your input, the system will generate knowledge. Next one, act. Here, machine learning and expert systems are there. We know what's the difference between machine learning and the expert system here. So one of the internal element for expert system is intelligence system. Next one, this is the illustrative solutions. We can go with the virtual agents. We can go with analytics through the iris, through the biometrics. Next one, cognitive robots are there. Nowadays, we're using online attendance system is there. Okay. In our universities, in our colleges, what we use here, online attendance system is there. So at the gate, we can identify the faces of the student, face features of the students by using the box plot. So what we identified, what we consider here, left cheek, right cheek, forehead, and chin is a box plot. So we can ignore ears, we can ignore hair, we can ignore other elements. So in that aspect, the computer vision will identify what is the face, what are the levels, what are the features of the face. Not only the face, that will ignore other information. So other information means we have to ignore that information. We don't want to consider. As per the image, that was good. But as per your requirement, that is not good. So based upon that box plot, we can identify the person, or the faculty, or the student. We have to use AUG methods. The AUG method will identify what is the resolution of the image. So maybe some person may use napkins, some persons may use mask, some persons may use goggles, some people use something. So here in that case, how can we recognize based upon the AUG method? It's the biggest question. So that's why in this intelligence system will act efficiently. That intelligence system will easily respond. Yes, perfectly. This person belongs to this class. This person belongs to this organization. Otherwise, it's just like abandoned person, irrelevant person. So that was automatic online attendance system. Coming to the next one, speech analytics. We know nowadays we're using different speech analytics, Siri and so on. Next one, recommendation systems. We discussed already. Next one, the final one is the data visualization. So what's the data visualization here? After completion of every aspect, we have to visualize the data. Nowadays we're using in the TV9, NTV. So that is the live streaming data. For sure, as for the live streaming data, you should apply remote sensing and GIS. Without remote sensing and GIS, we can't do anything. So suppose any cyclone is there, suppose any earthquake is there, already earthquake over, the Prime Minister or the Chief Minister will identify what are the prone areas. How can we identify all the areas? How can we map it? How can we generate the maps? How can we build an intelligence system through the geographic information system, through the remote sensing, through list-3 data or the remote sensing data? So that means it's a data visualization. After completion of every aspect, after completion of every machine learning algorithm output, then what we do here, we have to visualize the data in which manner? Perfect manner. So already we discussed. So this is the artificial intelligence. This is machine learning. This is the part of artificial intelligence. This is a subset of this one. And deep learning is the subset of machine learning, right? So here was the difference between AI, machine learning, and the deep learning here. So as for the artificial intelligence, we know the knowledge only, knowledge base only. In the machine learning, yeah, so some other aspects we can identify. But in this deep learning, exactly we should know. But in the transfer learning, perfect accuracy is there. So this is the integration. So in general, artificial intelligence has many integrations. The first one is physical AI. Second one, cognitive AI. Next one, sensory AI. And next one, general AI. Right? So here sensory AI, that means we can use sensors in artificial intelligence for computer vision and the IoT. We know. Physical AI, robotics and industrial automation. Cognitive means NLP, natural language processing. General AI means, so that will applicable for high precision values. And last one is explainable AI. Now, this is the real-time application for intelligence system. Up to now, so far what we discussed here, we discussed what are the basics of intelligence system, what are the applications of the intelligence systems, where we can apply, and what is our output. So is it filtered? Is it learned? Is it supervised or the unsupervised or the reinforcement? Is it structured or unstructured? Now this is the real-time application for how can we use our intelligence system or integration system in real world. Listen carefully. I hope. Hello.
Yes, sir. Yes, sir.
Yeah. Okay. Thank you. So this is a real-time application. This is a real-time application for how can we identify, not only identification, how can we detect, not only detection, how can we prevent identification, detection, and prevention of some disasters. This is applicable for the what I'm telling. This application is useful for all the disaster management problems. The first one is floods. Second one is forest fires. And the third one is landslides, earthquakes, and industrial gas leaks also. Okay. Here, coming to the first one, here's step number 1. I will explain in 10 steps. Then we can go with how can we gather the information. Step number 1, what we do here. So let's consider the first aspect. The first application is the forest fires or the wildfires. In these wildfires, what we do here, the first one, you have to respond. Some fire is there, you have to respond immediately. You have to save the neighbors. Okay, you have to save surrounded persons. It's the first step. What we do here, before exercising of what we do here, you have to identify what are the flames or what are the fires. What's the flame here? What's the range of the flame? What's the range of the fire? You have to identify. Okay. Second one, after identifying of some flame, you have to send such information to the central server. Our intelligence system is a server that will analyze. It is just like of the human brain. That is just like our human brain, not only human brain, think like human, act like the human. So that's why the central server must hold an intelligence. So after completion of, after retrieving of some information from flame, directly sends to which one? Central server. The central server will identify, okay, is it fire or not? How can we identify is it fire or not? Nowadays we are using fire images, okay, right? Orange is just like the fire image, fire color. The texture is orange or the red, or the combination of red and orange. Okay, it shows flame at the fire. But how can we tell is the exact fire or not? But in this intelligence system, for sure, we can easily identify. So this is the third one. We have to identify the robustness of the system. Coming to the fourth one here. So in this fourth step, what is the accuracy? What's the level of the accuracy? What's the level of the efficiency? Coming to the fifth one. So what we incorporate in the society, it should be eco-friendly. So it won't harm any person. It won't harm any animal. It won't harm any species. So that is the main motto of our intelligence system. Okay, nowadays we are planning and we are manufacturing, we are developing many intelligence systems, but some intelligence systems are not launching in the market. What is the reason here? Those are not eco-friendly. So you have to concentrate, you have to focus on the eco-friendly also. Is a very important aspect, eco-friendly. Next one, the sixth point. So you have to establish LAN connection, maybe IP or the TCP or the UDP, some protocol. You have to maintain some protocols between central server and the sensor. Step number 7, you have to classify how many files are there. Okay, what do you mean by file here? File is a combination of the hash. It's a combination of the hash and the file combination, some sticks and hash combination. So exact file is there, some fog is there, some smoke is there. Okay, so that's why you have to classify. You have to classify the data. Next one, step number 8. After identification of the file or the classification, then you have to send some information to neighbors, surrounded persons. Then APSDRF team is there. Andhra Pradesh State Disaster Response Force team is there. We will send some information to APSDRF. At the same time, same information we can send to the National Disaster Response Force. NDRF team is there. How can we send the information? You have to establish embedded system code here. Okay, we can develop a code in C program. We have to give some alert system to NDRF, APSDRF, something. So you should maintain the code perfectly. If the threshold was crossed, automatically that will beep the sound. Okay, that will send some information. Some information means we can send some SMS. We can send some email to NDRF, email to the neighbors. Okay, all are not aware about emails. So that's why we have to send SMS only. Coming to the ninth step, then after completion of every aspect, we have to post it in Semantic Web 3.0. So this is perfect intelligence system, Semantic Web 3.0. Now we are in Semantic Web 3.0. So previously, Internet Explorer is there. That was vanished. That was closed. Next one, Mozilla, Google Chrome. Next one, nowadays, something. Here, same thing here. We are switching from, we are moving from one area to the other area, from Internet Explorer to something, Mozilla to something, Chrome to something, like that. Now we are in the Semantic Web 3.0, Semantic Web 3.0 purely dedicated to intelligence system. This intelligence system holds high-end technologies. Okay, this is just like robotic technology. Step number 10. Step number 10, after completion of every aspect of the disasters, we have to display. So that's why in previous slide, I think what we discussed, visualize the data, visualization or the data visualization. How can we visualize the data? As for the computer science student, we can analyze, computer science faculty, we can analyze, okay, oscillation, maybe the histogram, pie chart or something. But as for geographic information expert, we have to visualize the data through maps. Okay, we can go with the different maps. So these are the 10 very, very important steps for intelligence system. Okay, let's consider. So this is the India map. Okay, so this is the main map. Now here, this is the Andhra Pradesh map. Now let's consider this is the GVMC map, Visakhapatnam map. Okay, right. Generally, what we observe here, vegetation or the leaf, that is in the color of green color. As per our eye contact, as per eye visibility, that is in green color. But that is not in the color of green. As per the satellite remote sensing, so exactly the color of the leaf is red color. So that's why this map generates what is a red color. It's the combination of all red color. The vegetation, maybe the urban area, something is there, maybe the rural area. Okay, so it's a map, it's the combination of everything here, right? So in that case, this is that was generated in 2016, right? So why that was generated in 2016 here? Here, some fires are there. At that time, huge fire is there. What is that, a huge fire? right? In Vishakhapatnam, some area, Kaparada Konda is there. In that Kaparada Konda, Kartik at the time of Kartika Paurnami, they used some candles. I think Dvipalu, right? So huge fire was occurred. So that's why I have collected from that image only, that data only. Okay. So this is main one, India map, then Andhra Pradesh map. This is a location map. Okay, right? So these are the different files. Now, how can we analyze data? So that's why our intelligence system, our topic is big data and artificial intelligence. Okay, so data analysis is there. We have to collect information. So this is the fire on date. So fire, so 31st October something is there. So fire area, right? So these are the areas, Simhachalam, Kambalakonda, some areas are there. So why we are collecting all this information? So you have to collect the information for data analysis. Then easily we can identify, we can tell this is a prone area. This is the fire prone area. This is the flood prone area. This is the earthquake prone area. Okay, this is industrial gas leakage prone area. Okay, nowadays we are using different prone areas. Yeah, for sure. So Vishakhapatnam, we already, you know, Vishakhapatnam is industrial area, industrial hub. Research is there. Okay, in 2020, LG Polymers gas leak was there. So at the time, many people were died. So it's a disaster area. So that's why we have to concentrate on what is the area and what are the dates, how many frames are there. Next one, these are the objectives. So before the objectives, this is the object of the problem. Okay, right? So first one, GVMC is there, Greater Visakhapatnam Municipal Corporation is there. As per, I think some research scholars are there. I think this is useful for, as per your research. First of all, you should identify your area. First of all, you should identify your area. Then area means area of the problem or something. Then you have to collect satellite information. Then you have to analyze the data. How can we analyze the data? Through the ontologies. Okay, semantic web perfectly suitable for ontologies. So at the same time, we can go with semantic web services are there. Artificial neural network systems are there. Then, so this is the UAV. In this UAV, what we follow here, drone remote sensing is there. I don't want to go. Okay, right? So 5 kilometers range, I can move in the forest area. After that, wild area is there. So that's why wildfires are there. We don't want to move. We don't want to go. Then what we use here, drone as a robot, drone as a system, drone as the intelligence system that will collect some information from wild area, the fire area. Then that information will collaborate it in our machine learning algorithms or artificial intelligence algorithms. Then we can take the decision. So how can we take the information? Sensor observation services are there. SOS services are there. Okay. So such type of sensing is called as drone remote sensing. Generally, we can go with 3 types of sensings. The first one, ground-borne sensing. Second one, airborne sensing. And the third one, satellite. First one, ground-borne. Next one, drone. That means airborne. Next one, satellite. That borne, spaceborne. Our topic is decision making, artificial intelligence, big data. How can we combine big data, artificial intelligence in intelligence systems? Then how can we take the decision? So these are the 3 basic things for decision making. The first one, I'm repeating once again. The first one, ground-borne. Second one, airborne. And the third one, spaceborne. These combinations are taken as what is decision making. We have to take the decision. Of course, I will collect information from ground. Maybe it has the accuracy of the 78%. Our sensors are not working properly. Then what we do here? My algorithm shows 78%. What happened? What was the lag here? Maybe some gap is there. So that's why this is not accurate. I will fly the drone that will collect some information from 5 kilometers to 10 kilometers range. Was a prone area, was a non-prone area, was a fire area, was a flood area. what's the gas leak area, what's the non-gas leak area, then that will give information. That information is the input to the machine learning or the deep learning or the transfer learning algorithm that will analyze, but it has the accuracy of the 80%. Ground-borne has 78%. Airborne has the 80%. So is it accurate? No, that is not accurate. We are discussing about intelligence systems. Accurate means what is for sure 99.99 or 100%. 70, that is not suitable. That is not perfect. That won't consider. So coming to the third one, spaceborne is there. As for the spaceborne, what we do here, we have to concentrate on list-3 data is there. Sentinel-2A data is there. Okay, right? That Sentinel-2A data, list-3 data, remote sensing data, we can collect such prone area information. Then we can analyze what are the past events, what are the past floods, what are the past fires, what are the past industrial gas leaks, what are the futures, what's the present here, right? So that information give to which one? Same artificial neural network or the machine learning algorithms. Maybe it has the accuracy of 95%. Then what we do here? We can combine ground-borne, airborne, and spaceborne. Then we can take the decision with the accuracy of 99.99%. So that is the importance of sensor observation services. This is the methodology. Okay, after completion of every aspect, then what we do here, you have to generate a susceptibility map. What is the susceptibility map here? So let's consider Visakhapatnam at the some Andhra Pradesh. In that Andhra Pradesh, so different industrial hubs are there. Okay, Kadapa, Karnoolu. Next one, Visakhapatnam and Vijayawada, Guntur. Next one, Nellore. Some other places are there. Okay, these are the industrial hubs in Andhra Pradesh. Some gas leak was there. What we do here? So you have to identify all the areas. Then you have to place in the map real time. Okay, not general. So you have to place the prone areas in the map. You have to show in the QGIS. Okay, so by using ArcGIS and QGIS, we can go with real-time monitoring data is there. Finally, susceptibility index map will show what is the range of the fire, what are the affected areas, what is the future fire, what will do. So based upon this futuristic information, generally, every organization must hold a vision and mission. Every organization or every industry must hold a vision and mission. Vision means it's the future. Mission means where we are. What we do here, now what we do. Same thing here. So in this susceptibility index map, what's the future fire that will identify what's the future fire also. So as for nowadays, we are using machine learning algorithms, neural network algorithms. Okay, here many inputs are there. Okay, as for the neural networks, we can go with the many inputs. Okay, right. So where as for the forest fire, the first input is slope, aspect, road density. Road density means, okay, let's consider some fire area is there, some forest area is there. What's the road density? So is it near to, this road is near to forest or not? We have to check out. That is also one input. So based upon that road density, we can take the decision. Next one, land use, land cover. Land use, land cover means, so in that forest area, so how much that was used? Was the land used? Was the land cover? So some urban areas are there. Next one, NDVI. So you have to generate normalized difference vegetation index. So which one is vegetation map? Which one is non-vegetation map? Then precipitation pattern. Suppose fire is there, we have to identify some tanks. Tank means it's not general tank. Okay, it's a pond. Generally, maybe rivers, some ponds, some water area. So you have to identify some precipitation patterns. Okay, we can stop. It's the first thing. Next one, what's the range of the weather? So is it feasible? Is it good? Is it humidity? Is it rainfall? Is it temperature? So is it climatic? Any changes are there? You have to identify all the conditions of the area. Next one, population density. Okay, let's consider, so this is a forest area, right? So surrounded some population is there. Okay, you have to identify what's the population of people. Then this is the data used. Okay, right? Generally, as for the big data, you have to collect information from topographical maps. So these are the different Survey of India maps as for space technology, as per space remote sensing. What we use here, topographical maps. You should use topographical maps. Coming to the next one, you after collecting of all information, then what we do here, analysis. You should use the analysis. Okay, so what's the past information, what's the present information. Then you can use cameras. So what's the purpose of the camera here? The camera will identify, the CC camera will identify was a fire range, was a fire area, was a fire range, was a smoke, something. So we can use different types of softwares also, right? So technology, semantic web, artificial neural network, spatial data mining, remote sensing, and GIS. Okay. As for the intelligence system, you should combine all the integrated technologies. That is the intelligence system. Once again, I'm telling. So intelligence system means that is not applicable for only this one, this technology. No. So it is applicable for broad areas of the networks, broad areas of the intelligence, maybe in IoT, maybe semantic web, maybe machine learning, deep learning, maybe the data mining, maybe the remote sensing, geographic information system, GPS, and so on. Okay, so this is the main map here. Okay, what we do, what is our vision? This is my vision. Okay, in this vision, so step number one, you have to select the area. Okay, this is the aspect of integration system. What we integrate here, so one side sensors, one side machine learning algorithms, one side robotic technology, one side remote sensing and GIS, one side semantic web. Finally, what we do, what is our output here? Susceptibility index map. So that is the final map. You have to generate such type of final maps. Okay, here data collection is there. In this data collection, we can go with remote sensing data, different types of the data. Then one side artificial neural network is there. We can take the decision either yes or no. Then we can finalize the information. Coming to the right side, burnt areas are there. What are the burnt areas? Okay, already affected areas, already fire areas, already flood areas. So these are the burnt or the affected areas. Then one side artificial neural network, one side remote sensing, and this we can combine data integration. We can integrate the data. So previously what we discussed here, airborne, spaceborne, groundborne is there. Then what we do, we can integrate the data, then we can take the decision. Okay, so finally what we generate here, susceptibility index map. This is the huge integrated system flowchart. Yeah, we know this one. Okay, input layers are there. So this is the artificial neural network. So here layer 1, layer 2, layer 3, and so on are there. Okay, so the input layer, hidden layers, then we can use activation function with the ReLU, with the sigmoid, then we can use some external forces, and finally what we do here, forest fire susceptibility map. So this is the neural network system. Okay, finally this is the generation. Okay, here you can consider this is the area map of the Visakhapatnam. Okay, this only this map will generate by ArcGIS. Okay, ArcGIS 10.3 only. Okay, so nowadays we are using different machine learning, Python programming, deep learning. Okay, so etc. But as for the ArcGIS, we can combine, we can incorporate. So machine learning, deep learning, transfer learning in ArcGIS only. We can integrate. Okay, so here this is the generation of the map here. So which one is fallow land, which one is the forest land, so which one is plantation, which one is the reservoir, which one is river. Okay, which one is tank here, which one is the wetland, which one is the mudland, which one is the agricultural field, what are the road networks are there. So this is the entire map we can generate through ArcGIS. Okay, so IoT for forest fires. Okay, I will explain here. So you have to build like this. Okay, so let's consider this architecture may host. Okay, is a flood or the non-flood, is a fire or the non-fire. So generally, this is a fire area. Sensor ranges are there, sensor nodes are there. We have to incorporate. We have to establish a tower with different sensors are there. One is the CCD camera is there. Next one, meteorological station, accurate weather station is there. Next one, we can transmit through cloud. Nowadays, we're using open source cloud platforms are there. Okay, here, so from left side to the right side is the central system or the central server. In between, what we use here is the cloud. So we can go with many free clouds are there. ThinkSpeak is a cloud. So we can easily use, okay, without paying up something. Just you have to register. Okay, you can give some information that will give information. Not only the information that will generate analysis, visualization for your information. Okay, how can we gather the information? Through the sensors. Here different trees are there. We can put different sensors. That tower will identify, the tower will take all the sensors. Okay, nowadays we are using radars. Okay, Kakinada radar is there. Vishakhapatnam at Kailasagiri, some radar is there. That radar has the range between 10 kilometers to the 100 kilometers. Okay, that will identify all the ships. Okay, that will monitor, that will navigate all the aeroplanes. Okay, is the tower, is a huge tower. The radar has the capacity, the radar has the range. Same thing here in our systems, in our areas, what we incorporate a pole or is a tower, or we can put all the sensors to which one here? A tree. So in between, from tower to the central system, from your area to the central system, you should use any cloud computing technology. So up to now, what we discussed, only big data, only AI, machine learning, deep learning. But you should use cloud computing, cloud as a platform. Cloud as a platform for is a transmission media between your prone area to the central system. Okay, it will connect from your area to the central system. So not only connecting, it will generate something. So that's why the free and the open source cloud platform is ThinkSpeak. So virtually we can generate like this. Okay, right? So this is the physically we can generate. So these are the trees. Virtually we have to think like that. So your problem is there, you have to think like that. Okay, so S0, S1, S3, something, S15, these are the different trees. Then you can incorporate different keys, and this is the security system is there, full secure. Okay, so you have to implement like this. So this is the window of generating some network. So you can generate, okay, how many trees are there. Okay, then size of the subgroup, then you can add something, you can add some network like this. Okay, this is the station, accurate weather station. It's a sensor. The sensor will identify weather forecasting. Is it precipitation? Is it rainfall? That finally sends to which one here? Central system here. Okay, right? So this is the information for air weather sensor. Air weather sensor will take the information from air. Okay, so where you can observe, I think you're observing. You are looking air weather sensor. Yes. Hello.
Yes, sir. Are we
Okay.
the
Thank you.
pollution
Thank you.
sensor?
Yes, sir. Thank you, sir. So where particulate matter 2.5 is there. Okay. Particulate matter 10 is there. Carbon dioxide is there. Okay. These are the different levels. These are the different inputs are there. Okay. So where particulate matter 2.5, particulate matter 10 is there, carbon dioxide is there, carbon monoxide, precipitation, something, every information is there. Finally, we can declare and we can finalize. Is it feasible to walk in that area or not? Is it good or bad? We can easily detect. How can we detect here? Through the air quality index. That air quality index will directly go to which one? Your system or your phone, or your registered phone is there. Okay, so in that phone, you can I think you can download an app, air weather app. Then you can link with your air weather sensor. Okay, you can calibrate that sensor. Calibration is very, very important. As per the drone, you have to calibrate it. As for the air weather, you have to calibrate it. Every sensor must hold calibration. Okay, so If it is calibrated, then easily that will navigate, that will collect some latitude, longitude, and altitude. Not only latitude, longitude, and altitude, it will collect some information from environment also, and automatically that will give. So this air is moderate. Here, look at here at mobile. So moderate is there. Moderate means okay, you can go. Simply, it's a decision. It's a decision making. So based upon the big data and the IoT, what we do here? No, it's the low, it's the moderate, it's the high. That indicates what is you can go. Otherwise, you have to stop. That is the decision. So the decision making applicable for air weather pollution sensor in real time. Okay, so this is the D3D sensor. This sensor will identify all the aspects of fogs, smokes, and so on. Okay, so this is the thermal camera. Okay, in night, in dark also, that will identify the objects. Okay, nowadays we are using Kalman filter algorithm. I think already you're all heard about Kalman filter algorithm. So this is the image processing algorithm. In that image processing algorithm, what we do here, what you want, we can collect. Otherwise, what we do, the background knowledge will be ignored. Same thing here. So what we do here, the D3D CC camera will identify what are the range, what are the videos, what are the images of the fog or the fire. Okay, so here, look at here. This one is left side, air is moderate. That means air quality index that will show 128, particulate matter 69, particulate matter 132, carbon dioxide 381, but air is moderate. Okay, but humidity is the 38%. Children, look at here, breathing discomfort. Okay, that indicates what is moderate, indicates it's a discomfort. So that is the pattern. That is the decision making for your pattern here. Okay, right side. So one sensor is there that will sense surrounding information up to the range of 1 kilometer only. Okay, 1 kilometer only. So I would like to go from 1 kilometer to the 5 kilometers. You have to renew. So you have to take all the features from air quality sensor or the air weather sensor. Then that will give access to the 1 kilometer to the 5 kilometers, 5 to the 10 kilometers, 10 kilometers to the 15 kilometers. That's it. So then air is moderate. Moderate means that will sense and that will take the decision. Okay, so these are the aspects. This is the information relevant to the air monitor. After completion of sensing the information, that will send to the mail. So this is the mail information. Okay, so Excel sheet will generate from our email. Here, air quality is there, particulate matter, PM10 something, carbon dioxide, temperature is there. Here, based upon this one, we can go with decision. Next one, deep learning technique. We know object tracking, right? So Kalman filter was a Kalman filter algorithm here. Background subtraction is there. So here, this is the fire. This is the result of what we discussed here. Okay, listen. So this is the exactly I think in 2014. So in Vishakhapatnam, huge fire was there. Okay, at the time they used helicopters. Okay, human is not supporting. Okay, that's why they use helicopters. Okay, it's a huge fire. Okay, what we do here, we can take an image. Okay, image. Otherwise, we can take video that will give to the Kalman filter algorithm that will filter. Okay, it's a background. Black is there. Black means I don't want. Okay, it's the ignorable thing. So what do you want here? Only flame or the red color or the orange color or the combination of the red and orange. Okay, then that will generate. So here maps are there that will generate. Okay, is it correct or not? Is it flammable or non-flammable? So is it fire or not? Okay, this is the flammable objects. Okay, so these are the inputs what we discuss here: slope, aspect, elevation, land use, and DVI something. Okay, after completion of the land use and land cover, what we do here? So this is the data visualization for an expert system. So this is the land use land cover first map. soil map. Why we are using soil map, drainage map? Okay, all maps are there. Why? What's the importance of all the maps here? Suppose is there any fire area? Okay, we have to identify nearest tanks. Nearest tanks means what are the water bodies? Water bodies nearest to the fire area. So that's why what we need drainage. You require drainage. Well, you need soil type. So that's why you should gather all the information of your area. Okay, so here brown clay soil is there. So different soils, a clay soil is there, mud soil is there, red soil is there. Okay, so this is a geology map for area. So this is a drainage map. So that is the indication of drainage map. So this is a slope map. Slope map means we can identify what's the slope areas. Then this is the final one. So this is the susceptibility index map here, right? So in this map, here green color that indicates what is areas or the villages. Okay, at the same time high let's consider high maps are there, low maps are there. Okay, high maps indicates what is high prone areas, low prone areas. Okay, forest fire susceptibility index map that will generate high areas, low areas, that indicates high prone areas, low prone areas. Okay, right? So finally, this is the prone area map for system. Next one, this is my final conclusion. What I used here after completion of gathering information, air quality indexing, you have to send information to NDRF, APSDRF. Okay, at the same time, nearest persons are surrounded persons. Okay, so this is decision support system. Okay, this is a decision support system for intelligence systems. Okay, intelligence systems by default, it has the feature of the decision making, other decision supporting. Okay, that will combine all the areas. It should be used for health management. It should be useful for disaster management. It should be useful for industrial IoT and so on. Okay, sir, any queries? Hello, any queries in that?
Sir, a small doubt, sir.
Tell me, sir, please, sir.
What are the other alternatives other than this cloud, sir, to save this huge data, big data?
Only cloud, sir. So virtual clouds are there, my clouds are there, own clouds are there. We have to save our data in the cloud only, sir. So
Okay,
data
okay.
volume is there, data cube is there, that is supporting to up to 1 terabyte, 2 terabytes. It has the range. Beyond that, we have to use cloud, sir.
Why this? Okay, sir. Another one. Why this California fire accident that we have seen, sir, in USA,
Yes, sir.
Los Angeles?
Yes, sir. Yes, sir. Los Angeles.
Why
John
they
8th.
why they couldn't prevent that one, sir? That accident.
So the basic reason is there is no intelligence system. They have sensors. They have many algorithms. They have many technologies. But there is no perfect intelligence system for Los Angeles accident, sir. Fire accident.
Okay. Any queries from the audience? You can post in the chat box also if you need.
Good evening, sir.
Good evening, madam. Please tell me.
First of all, thank you for the great session. I have a doubt, sir,
Yes, ma'am.
regarding the smart attendance system.
Hmm.
Sir, if there are any two identical twins are there in the class,
Okay.
so how could it recognize? Like,
So that's why we have to introduce correlation, exact correlation. So generally nose is same, lips are same, left cheek, right cheek is same, but some moles are there. Some chin has some sign. Okay, some what I say here, right? Some moles, some signs, some scares are there. Based upon that one, we can identify.
Okay. If we couldn't find any difference between the two faces, then then it will be a challenge to air, isn't it?
Of course, yes, exactly.
Then is there any other what solution for this? Like iris is the one solution for this, but is there any?
Iris, yes,
Yeah,
iris and biometric is the
taking the
solution.
iris. Yeah.
Yeah, iris and biometric, that is okay, but automatic system is there. We are discussing about automatic online attendance system.
Sir.
So in that case, we can use this one. So nowadays, street beggars are there. Okay, street beggars and small childs are there. Okay, they don't know how can we go. Okay, at the time, what we do here, we can gather some persons, then we can hand over to nearest other seva center is there. Then based upon their iris and biometric, easily we can find out parents' address, parents' phone numbers. We can easily hand over. It's a method. But in this automatic online attendance system, we can't use iris and the biometric.
Okay, sir. Thank you.
Okay, ma'am.
Hello, sir.
Yeah, please tell me.
Sir, this is Vijay Raju.
Yes, sir. Please tell me, sir.
Sir, in order to process this huge amount of data, is there any cloud service really available for the academicians?
Yes, sir. Yes, sir. ThinkSpeak, sir. ThinkSpeak is open source platform for cloud computing, sir.
ThinkSpeak, sir.
ThinkSpeak, sir. ThinkSpeak. ThinkSpeak, sir.
Okay.
This is the open source platform for cloud computing, sir.
Okay, sir.
We can register,
Yes,
then
sir.
we can log in, then we can upload our code into the ThinkSpeak. Automatically, that will generate. So what are the visualization aspects?
There we can perform computation also, sir.
Yeah, that will perform.
Okay. Thank you.
Yes, sir. Any doubts from audience? So this is the general aspect. What I discussed here. So intelligence systems are nowadays very useful. So that's why what Davi sir asked. California fires, okay, recent floods and tsunamis, earthquakes, okay, all are based upon this intelligence system. So without intelligence system, we can't take an exact decision. Any question? Any questions from audience?
Anybody? Some madam is asking. She told that she put that one chat box, but I couldn't find that one. Madam, you can ask, madam. No problem.
Today's class is very inspirable class, sir.
Thank you,
But
madam.
give any suggestion about the simple projects how to develop for at home and college levels and
Yes, madam. Yes, madam.
any labs is nearby.
Yes, madam. Yes, madam. You can use simple sensors temperature sensor, humidity sensor, precipitation sensor, rainfall sensor. Okay, these sensors we can deploy any of the platform by using any Raspberry Pi or Arduino. Then simple program we can implement in embedded systems with the help of C programming. Okay, after implementing of the C programming in embedded systems, then that will directly connect it to the machine learning algorithm. That machine learning algorithm will tell what's the accuracy of this one. So this is the simplest way, ma'am.
Thank you, sir.
Thank you, sir.
Yes, sir.
Hello, sir.
Yes, ma'am.
Sir, good evening, sir. I'm Vinila. If suppose if we want to do any fire detection project, where we can collect the data sets, sir?
You have to collect a data set from Bhuvan website. Bhuvan, BHUVAN, Bhuvan website. So this is purely from ISRO.
Okay, sir.
Mm.
Sir, is it possible only on for big data? We can first we can consider very small data and then we can implement it to big data.
Sorry, repeat once again.
That is it. This detection is actually for big data collection, right? Is it possible only for big data collection, or we can start
No.
with
It
very
is
small data set?
applicable. It is applicable for low level, moderate, and high level also.
Okay, sir. Okay, sir. Thank you.
Okay,
Can you tell me once again the website name, sir?
Bhuvan, BHUVAN.
Okay, sir. Thank you, sir.
Okay, ma'am.
Okay, any queries? Okay, if not there, then we can go for other session. A big thank you to Dr. G. Narasimha sir for an excellent session on big data and AI, building intelligent systems. Your talk was both informative and inspiring, sir.
Thank you,
we are
sir.
grateful for the knowledge and insights you have shared with us. Thank you once again for making this session a memorable one, sir.
Thank you, sir. Thank you so much, sir. Thank you, sir.
Now, as we transition into our next session, it's my pleasure to introduce Dr. Sri Panikrishna Kari, who will be delivering a session on AI for business intelligence and decision making. Already I introduced Dr. Pani, sir. He's from Andhra Pradesh NIT. Excellent messages he has given for 2 sessions already. Dr. Fani will guide us on how this AI and deep learning technologies can drive data-driven decision-making business and for fostering this innovation and efficiency. Dr. Fani, sir, over to you. We look forward to your session, sir.
Okay. Good evening, sir. I believe I am audible.
It's audible, sir.
Okay. I think still the presentation is on. Thank you. So I thought of taking a practical approach for this session because last 2 sessions of mine are bit theory kind of a thing, and in current generation more practice is needed, and getting our hands dirty is what we have to do because we have to delve into practice. So in this process, looking at the audience portfolios, it is observed that you are from across the spectrum. So in this context, let me first let me try to share my screen. I will walk you through various reports and various repositories and practices. So in that context, so you want to be an entrepreneur, that's great. But whenever you want to make any kind of idea, validations and all these things, you will be taking the support of AI for sure. So in that, what are various AI-powered innovations that are part of the business intelligence and decision making, which will be a part of an entrepreneur. So usually they have to embrace machine learning for sure, because you will be have to forecasting the market shifts, customer segmentation, trend identification. So for all these case scenarios, you need the machine learning. And machine learning also supports for computer vision and natural language processing and other things. So natural language processing is when you have to delve through a lot of documents, when you want to understand the summarization of an document. And sometimes in the whenever you have from different language, when you're getting a context from different language, when you want to convert into different language, there even in those scenarios you will be using. And currently when the Gen A, because with the rise in deep learning, who are part of my first session, they will be already aware that the Gen A driving force is basically a deep learning. And this has increased the capability and has taken the intelligence to a new level, because with the availability of the information and also creation of new information. So with this, when we look at any kind of a business or a startup or anything like that, the first thing, any startup starts with an idea. But when you're picking up an idea, that should be catering to the needs of lots of people, right? Without it catering to the needs of people, it is of no use. So before designing any idea or a solution, any entrepreneur has to look at is, who is my customer and what are his needs, and how does he look like, or what is his characteristics, okay? How much can he spend, and all these things. So based upon that, they can promote for those customers. So that is one part of it. So customer segmentation is one part of it. And during the customer segmentation, when you want to do some sort of a machine learning aspect, the basic thing will be an clustering, which is part of the unsupervised version. So usually how does an customer data look like is something like this. When they want to do in customer segmentation, yeah, this is how a customer, okay, de-identified customer, what is the product for a basic recommendation system. So what their products they purchased, what is the complaints they have received, money spent, and various things. These are like the features on the customer. Now they want to know what are the various customers. They want to group the customers so that they can know how many products do they purchase. Are they good customers, or they're like very aggressive customers, or the neutral customers? Or if he is a customer coming in, how much money can he spend? Because based upon the customer spending capability, you have to showcase the product. So in that context, we are supposed to do some sort of an clustering kind of a thing. So for that, first we have to normalize the data. So for normalization of the data, whenever you're getting an input data, usually you normalize the data. The reason is, when the data is coming, individual feature can be of different dynamic range. Okay, because customer id of a different range, number of products purchased will be of different range. So number of products purchased usually will be 1 to 5 or 6. It cannot be more than 100. But when you look at money spent, usually it will be from $50 to $1,500 to $2,000. So products purchased dynamic range will be 1 to 10, but money spent dynamic range will be 2,000, sorry, $50 to $1,500. So with that reason, you are supposed to normalize those input features. So we will be normalizing with the help of mean and standard deviation, all these things. So after the normalization of the features, you can take up a standard any machine learning uh, uh, library in Python, and you can do the clustering part. So here we will be using something called as a k-means clustering. So they have employed a k-means clustering, and scikit-learn is a library which they have used. So here, if you see it's a Python code, it is an sklearn. So scikit-learn, this sklearn is an abbreviation of scikit-learn, SCIKATLERN. Okay. So you know to re-implement the machine learning models because there are already libraries existing. So you can use an off-the-shelf algorithms here, and you're looking for segmentation, the customer segmentation. So it actually falls under clustering, and one of the clustering methods is k-means. So you will be using a k-means algorithm. and picking up the data after normalizations and stuff. You will be applying this k-means. You will be running just k-means of, you will be initiating the k-means and maximum iterations, and random states will be 42. So that will become a k-means model. And now k-means model dot fit, and you will give the customer data. Okay. By giving the customer data to this model, and you're saying fit is nothing but training the model. So with this simple statement, with the provided data, the k-means is going to being fit with for the given data, and there are more number any n number of libraries, but here we're only sticking to scikit-learn. So finally, it is going to, once the algorithm has run, so it will identify the clusters of different users, and you from that you get to know, okay, this customer is of this kind of a nature and this kind of a spending. And one of the drawbacks or limitations of k-means clustering is you have to say k before in k number, like the number of clusters, because into how many segments you want to divide your customers into. So that kind of a number need to be given. So there are various approaches, that the elbow method, average Silhouette method, gap statistics method. Okay. So you can pick up anything straight away and you can use it. And after that, whenever if you want to plot the data, you can straight away plot the data. And this is like learning curve that they're showing that, okay, they are able to do the clustering part very perfectly. So it is actually squared error. It is sum of squared distances. So sum of squared distance is falling. So that means the clustering is happening properly. And finally, after the k-means cluster model has been fit, we will do certain predictions so that we can see the visualization of various customers. So looking at various customers, when they got clustered, so we can see that this first customer has fallen into fourth cluster, second customer has fallen into zeroth cluster, and so on and so forth. So these two customers has fallen into one cluster, second, fourth and fifth customer has fallen into different clusters. So this way we have clustered the customers. So based upon that, we get to know, okay, tomorrow, if a particular cluster for a particular customer comes. So based upon the cluster, we can say that, okay, he might purchase these many products, or he might give certain complaint, he will not give certain complaint, or this much money has been spent. So this is how some of the decision makings can be made while recommendation systems, because a customer has come with similar purchasing capability or something like that. So whenever they're looking, they can do a better recommendation system and better analysis of the customer. So always a data driven suggestions or data driven ideas are always better. And this is just one part of a complete module that a entrepreneur can pick up, that is customer segmentation. And let us look yes, so along with that, if you want to find the trends, like there are multiple publications. So one popular publication is identifying a trend, because whenever you're starting a startup, you should be knowing that what is the trend that is going to come up, kind of a thing. Market trend prediction is very much needed. So for that, again, deep learning models are being helpful, because if you predict the trend, if you're working on that, then it will be very much helpful for the person. And whenever you say trend, whenever it involves a temporal analysis, so usually take it for granted, as mentioned in the last class or last session, it will be always a CNN plus LSTM combination. A CNN plus LSTM combination will be extracting the features based upon which they will be trying to predict these trends. And sometimes to augment the data, because always data is very much crucial for the deep learning. So for augmenting the data, they use something called as a GAN, generative adversarial network. So it will be simulating more. If you see here from noise, there is a generator, and from generator, it is giving an augmentation, data augmentation kind of thing. So even though you have limited amount of data, using the GANs, you can create more number of data, and also it can augment the data while training your model. But keep this in mind, whenever there is a trend, whenever you have to do temporal analysis, take it for granted, it will be a CNN plus LSTM combination. Now, people have been speaking about, yes, machine learning is very much required. And one machine learning thing which we discussed here is clustering. But in the life of an entrepreneur, he might be needing different kind of machine learning algorithms at different kind of different phases of his life. So for that reason, you can pick up this cheat sheet. So it is a cheat sheet from scikit-learn. So based upon your task and the data you are having availability, so you can start and you want to know whether you want to predict something as a category, or you want to predict a continuous variable. If you want to have a continuous variable need to be predicted, then it goes into regression or dimensionality reduction. If you want to predict something like a category, like yes or no, up or down, something like that, or classes, so then it will be going into this direction. And one of those two things is, one is if you have labeled data. So if you have labeled data, so you can go to the classification task, and you can do something like SVM, support vector machines, naive Bayes, random forest, or something like that. Okay, this is top one is the classification, and the bottom one is you don't have the labels, but you still want to do some sort of a categorization. So that's where the clustering techniques will come. If you see k-means that we have recently we have just covered, that is the k-means thing here. Are you able to see my mouse?
No, sir.
No, you
Oh,
not
yes, sir. No, yes, yes. Okay, sir. Okay, sir.
Yes,
Now
sir,
we
we are able to see.
Okay, you're able to see. So based upon different tasks that the particular entrepreneur has at this point of time, they can do. Because for trend analysis, he are supposed to do a regression task. Okay, how many customers will come? That is also regression task. Is he a good customer or a bad customer? Then that is a classification task. Is the company is going to grow or not? That is a classification. Is the company okay, if it's going to grow, how much it is going to grow? Like it can grow 1%, it can go 3%, or it can go 10%. So that will come under regression task. Okay, so continuous values, when you want to predict continuous values, that will be coming as regression. When you want to estimate or predict the discrete values, then that comes under the classification. Sometimes you want to do an underlying analysis of various groups, like in social media or anywhere. You want to know, okay, these people are falling into these groups. So that's where the clustering will come into picture. And another one is the dimensionality reduction. So many times what happens is, you have a feature space and you want to see that feature space, but the problem is usually features will be of higher dimension, like 10 dimension, 20 dimension, 30 dimension. But our eyes can see only 2 dimensions or 3 dimensions. So the relationships in the higher dimension need to be visualized in 2 dimension or 3 dimension. Then you will be using something called as dimensionality reduction. So that is where the principal component analysis is one of the most important thing. Actually, you might have heard about eigenvectors and eigenvalues, right? So PCA is actually based upon eigenvectors and eigenvalues. So this way, you can search for something called a scikit-learn cheat sheet. So this is what pops up, and from here, like as a starting point, you don't know what algorithm to pick, but you know you have a clarity on your task. Then this flow can help you out. And along with that, there are various there are various machine learning cheat sheets that are available. I'm new to Zoom, so it's a bit problematic for me. So in the same way, whenever you want to know, you want to have a shortcut of learning of machine learning. So usually there are a lot of cheat sheets online available. So you can see whenever this one, for example. So basically many people are speaking about supervised learning, unsupervised learning, or reinforcement learning, or semi-supervised learning, right? And something like that, right? So in those scenarios, okay, what is unsupervised learning? In unsupervised learning, you have associations or clustering. Under supervised learning, you have in tree-based models or linear models, something like that, right? So again, under linear models, what are the names of different models like linear regression, logistic regression, ridge regression? Take a note, even though logistic regression is a regression, the name is regression, but it is actually a classification. And lasso regression, decision trees, random forests. Like, see, then why are they used for? What are their use cases, applications, and what are their advantages and disadvantages? So when you have such a cheat sheet, so based upon your task, you can say, okay, based upon what you are looking for, okay, I can allow these disadvantages, these are the advantages which I need, and do that particular methodology. So this particular report or the write-up gives you various algorithms and what are the advantages, disadvantages, and descriptions. So it will give you a jump start for you to into the world of machine learning. Of course, the math is very much important, but sometimes the need drive need what you have in you drives you towards learning that math. So for that reason, I'm showing this. So because you might learn something from a mathematical point of view and everything, but if it doesn't fit to the task in hand, so then it is of no use. So for that reason, if you go through this cheat sheet, you get to know, okay, you have a task in hand and which algorithm is matching to the task. And then you can go to the background of that machine learning algorithm. And whenever you want to look a bit on math part of it, there is one more cheat sheet from Stanford, machine learning tips and tricks cheat sheet. So this will be helpful for people to get a gist on various crucial things from a performance point of view, not from a training, from a performance evaluation point of view, or if a model is working good or not. So for that, because okay, you trained model, it is giving something, okay, but is it working good or not? Is 99% accuracy good or not for this task? Because sometimes 99% might be looking good for certain tasks, but 99% might not be good for certain tasks. Okay. So one example we take usually is in the medical community. During the rainy season, usually people come with fever, right? So 95% of the time it will be a normal fever or a viral fever, but only 5% will be falling under something like a malaria, typhoid, or something like jaundice or something like that, jaundice or something like that, right? So there, 95% of the time it will be a normal fever only. Only 5% of the time, usually it will be jaundice. Now, but if there is one idiotic machine learning model which is sitting there and saying that whoever is coming in, it is saying that this is a normal fever only. Even in those scenarios, that model is 95% accurate, because 95% of the patients who are coming in the normal fever people. So even though that doesn't have any intelligence, automatically it is having 90% of the accuracy, because a priori probability of this particular task is at 0.95. So that is the reason sometimes accuracy metric might not fit for particular task. So based upon those tasks, what you're supposed to do, and what is the training data, what is the validation data, what is the test set data, because many a times people confuse between validation data and test data. So these are the things as an entrepreneur one should be knowing of, because you as an entrepreneur one need not know what is everything about nuts and bolts of algorithms and anything. But as an entrepreneur, you should not be taken right by your subordinates. right? So for that reason, you should at least know some technical aspects for upcoming entrepreneurs, and how the data set will be broken, their cross validation, how regularization will help you, various regularizers, and what sort of model. This is an underfit, this is an just a fit or rightly fit, balanced fit, this is an overfit. Even though this is the correctly fitting, like it's my fitting to all the samples, but it is also fitting to the error. So this should not happen. So this is what is expected, right? So it might be a regression task, it might be a classification task. So you will be getting a gist on what the things you are supposed to know before delving into ML. So these are like a jump start notes for you to learn. So with this, this is basic machine learning. But in current generation, many of the enterprises are depending majorly on Gen AI. So I thought, why don't we just have a example on how Gen AI means. One of the classic example they say about Gen AI is something like ChatGPT. Now, but when enterprises, what happens is you are not allowed to give your data or give your thing for the publicly, the ChatGPT or something like that, because such kind of information might be leaked and the business information can be leaked. So for that reason, usually people prefer to have something locally only on their host machines. So we have one such thing. As I said, I like Dockers. So let me initiate my Docker. Yeah. So Olama Docker is started. So let me run a simple Llama model, which is like a chat GPT. So this is, I am initiating, I have already initialized the Olama Docker. So in that I am running this function. So up to here, this part is initializing of my starting of my Docker. So Docker is something which I said yesterday in the yesterday session. In the yesterday session, I have spoke, right? So this is the command which I'm passing through to the Docker. Okay. So Llama 3.2, as I have been speaking for a very long time, that is what is being used in your WhatsApp Meta AI. Okay. It is loading the model and it is ready, as it is only 1 billion parameter. So if you have someone can throw a question that you want me to ask this model. By the way, this model is running locally only. Anyone has a question to throw at this model? No question. Don't you want to ask anything? Some question to the AI model.
Is it one built-in model, sir?
Huh?
Is it one built-in model,
This is
sir?
running on the host machine, sir. This is running on the host machine. We are not taking the support of the internet. This is running on the host machine. You can give me any question. Oh, role of AI in startups. Okay, this is a very simple question. So this is what it is going to generate. Like, okay, this artificial intelligence AI plays a significant role in various aspects of startups, so on and so forth. It is giving some popular AI technologies or machine learning, natural language processing, computer vision, so on and so forth. Okay. So this way, whenever in a startup, when you're in a startup, when you want to have clarity on something or you want to know something, you can straight away ask this question. Now, but if you see, I loaded a model which is called as Llama 3.21b. That is very simple model with only 1 billion parameters. Now, the intelligence that this model holds is very low. Now, we can come out. Say, I want to load another bigger model, which is of 42 billion parameters. So from 1 billion parameters to 42 billion parameters. So it takes some time to load, but okay, as it said, local, already it is okay, done. Great. So let me give the same question. So it is taking a second time. It's because actually the model is big, so it is taking certain time to print. Okay. See, if you see, the first model will be more generic and casual kind of a thing. This will be more precise and more effective kind of a thing. So from a pipeline point of view, even though see, if you see the first model's responses, it started with artificial only, but the way it went, it is more generic in nature. It's more casual in nature. But when we had a very powerful model in place, it is more precise and accurate and gives you more updated information. And engine helps you deliver personalized. So I can show you the. So from the system monitor, it will be evident that we are running on our machine. And if you look at the network is taking only the 200 kbps odd, which is because I am running the Zoom, right? So the network is being taken in this scenario. So I'm not communicating anywhere from the internet, but yet the model is running. To prove you more, so we can have. So it is. I have a GPU on time. So this is taking around 1233 MB only, but it should not be taking that much, it will be taking more. Taking only 1241 MB, but it's taking very low GPU. Maybe it is running on CPU, has been not loaded onto. Okay, fine. So if you look at the output of the first model, it is very generic. It is very simple, and it is saying that okay, for automation, AI can automate repetitive tasks. Data analytics, AI powered tools can analyze. It is giving all the way to supply chain optimization, innovation incubation, and all these things. Now these are also repeated here to some extent, but improved efficiency. How are you going to improve the efficiency through marketing and customer acquisition? There is no concept of customer acquisitions here. It has said something like a marketing, okay, but what in marketing, why you want to do marketing kind of a thing, it has been extended here, and so on and so forth. It will be defining more and more. So this is everything is running locally, and you can have some other models fine-tuned for your startup or business. So that kind of a knowledge can be placed in this through fine-tuning. Let me stop this model for the time being. Now, but this is running everything on terminal. I don't know why suddenly. Yeah, suddenly. So it is running here. It's fine, but this is on terminal level. Now, many a times, what happens is people might be having certain documents, and those documents need to be analyzed very easily. So, which is not possible from this terminal. So, what they usually do is, so with the backend of this Olama, they have something called as Web UI. So Web UI is an open source So if you see here, it is local host on 3000 port. So that means I am using my own local host machine only. So this will be a GUI version, which is again an instruct model. So here it will be more comfortable to you to have a chat or something like that. So this looks like an ChatGPT kind of an thing, and you can actually write around. Give me ideas. So I straight away asked certain thing, but you can have an option of selecting the models also here. So the already previously loaded models on my machine are like Llama 3.1, Llama 3.2, Llama 3.3, Nimatron from NVIDIA. So these models are already loaded on my system. So delete it. So let me pick up a different model, a simpler model. So it will be more of an simpler model. If you observe, this is a Llama 3.1 8 billion parameter, which is an instruct model with a floating point of 16. So yesterday we have spoken, right? There will be quantization of the models while deploying. So you can have int 8, floating point 16, floating point 32. This is actually floating point 16. I have exited from the model, right? As it is running on one premise, so it is taking certain time to get loaded, and it should be giving certain answers. But I will give you how it does it look like. Okay. So this is how whenever I ask a question, so I uploaded in PhD Viva voice like document, and on that I have a question: what is NLM has explained it, explaining from whenever you want to analyze or understand a document, you can upload that particular file to the system. Because why we are supposed to upload the documents is there is something called as AI hallucination. When you don't want to get into the AI hallucination, usually you
Sir, your voice is not audible, sir. Sir, Funny, sir. Your voice is not audible, sir. Funny, sir.
Sir, for how long I have lost? I was lost.
What 1 minute, sir. 1, 2
Only
minutes.
1 minute. Okay, fine, fine.
In your PhD work, you are saying something at that time.
Yeah, it's a PhD Viva. So I want to Viva was presentation or something. So in the PhD Viva's presentation, I want to know what are the information that was placed in this PhD Viva's presentation rather going to the complete document. So what is this NLM? I asked a simple document. So here it has mentioned what NLM stands for. In NLM algorithms are trained at data from past measurements and something. This is not the information that is coming from the model. This is the information that is coming from the document. So whenever a research paper comes and you want to understand that research paper, so rather going through that research paper, you can directly ask that question of that research paper and ask the questions on that research paper and get the things. This is also called as PDF chatting, basically because you are chatting with a PDF. So opposite side, there is no person. It's actually PDF. So actually you're asking the questions and it is giving the answers. So if you want to do something like that on your machines with a 16 GB RAM or a 62 GB RAM, sorry, 32 GB RAM. So what I'm using is something called as Olama. Okay. So Olama, if you want to install on Linux, it's a very straightforward, simple instruction. If you go to your terminal and drop this, Olama models with Olama platform will be called whatever it's.
Sir, again, voice is not audible, sir. Some disturbance has occurred, I think. Funny, sir. Funny, sir. Voice not audible, sir.
Sorry, sir. I think my internet is a bit unstable. Okay, give me 1 second. Okay, now it's fine. So if you want to do something similar on your machines, this will be Olama. Olama, you can you have the installation instructions here, and know if you have want to do with a Docker. So because it will be a clean installation and clean removal, and all the necessary packages also will be installed. So you can have this Docker image also, which is available. And what are various models that are available? Because I'm currently using Llama 3.2 or 3.3 or 3.1, but you have various libraries of models which are available on this. So you can use the model of your choice. It need not be a natural language processing. It can be also an image description kind of a models. And if you look at the observe the models, like Llama 3.3, it has 70 billion parameters. In DeepSeek, you have variants of it: 1.5 billion parameters, 70 billion, 8 billion, 14 billion, all the way to 671 billion. So you have the model of different parameters. So based upon your compute capabilities, you can have from 1.5 billion, which you can run on a 16 GB RAM or a 30 GB RAM, to all the way to 671 billion parameters, where you need at least 150, more than 150 GB of GPU RAM. Whenever you want to pull a model, all these models, you can pull it as Olama pull Llama 3.2 or 5.4 or something like that. So the model will be pulled. If you want to run that model, it is just like replacing pull with run. So you can run that. If you want to remove the model, all you have to do is RM, remove. And there are various tutorials that are available, which will be saying that, okay, how to run LLMs locally. And because large language models are the trend of the day. So there are various reports and places where you can do it. Okay. Then you might be having one more question. Is it only about chatting with the things, and is it only about reading the documents and stuff? No, it can do many more. If you have an LLM in the backend, you can actually create agents. So there is a package called as LangChain, with which you can create various agents and various pipelines, where you can use natural language processing and also vision models. Okay, so LangChain is the thing for creation of agents. But when you have something like say agents that need to be created, and you have to deploy them at enterprise level, so there is another package called as PyData. LangChain is good for developers, and also it is looking at enterprise now. But in a shorter span, if you want to do something like enterprise, one simpler way to get onto agents is the package called as PyData. So this is the PyData. So this PyData is a great tool for you to create agents in a simpler way, and also with enterprise grade. So one of simple agent is you want to do some sort of a web search and you want to collate the complete information. So that is an agent. So we have created an agent. We want an agent which goes on to the websites or on the into search engine, and it collects the information of your task and it reports back to you. So for this, it uses something called the DuckDuckGo headless web browser. So you can use a Chrome or you can use DuckDuckGo also. So here we are using a DuckDuckGo thing. And how to install all these things were already available on this web page. This is termed as PhiData, PHIDATA. So how does an agent look like and what can an agent do? Let me show you here. So keep in mind, I am everything, even though it is doing a web search, I am not using the model which is hosted online like OpenAI. I'm using it locally. So I'm running an agent. So I have a question in hand. So I asked it to go online and do a particular search and report back the answers for me. Okay. Let me turn this off once again. Because everything I'm running on single machine. I have to, because the resources will be shared. Still working. Okay, the GPU has been fogged. Sorry, I couldn't show the response. Maybe if in the meantime, before the completion, if it does, it is okay. So if you have created an agent, that agent will give you a response of all the information that is collated from online. And also you can have a financial agent. So it goes online and search for a particular thing or a particular, say, company. It can do some financial analysis on the company and it can give the responses. So all those things are available here. So you can create multiple agents and do the thing. So till this point of time, we're doing locally. Okay. But sometimes if you have a freedom of doing it on the cloud, there is one good place that is called as Google Notebook LM. So which I have mentioned last time. So Google Notebook LM, this is a great place. So where you can upload the documents which you want to analyze or which you want to speak about. And whenever you upload those documents, automatically it is going to do a topic modeling and it is also going to find an entities of the documents. So as these documents are about battery energy management in batteries, so it has automatically identified, okay, state of health across diverse conditions, what SOH estimation, modify offers, and so on and so forth. So this is everything happen in cloud. So I can ask what is SOH? Okay, that is actually state of health. So it is processing it, and it will give out the answers based upon the documents that we have uploaded. And if you want to include those documents, some documents what you want to include or resources what you don't want to include can be done here. So now what is SOH? When I ask this question, it has said, okay, SOH is actually state of health. It's an measure of batteries and everything, and definitions of SOH is capacity based, resistance based, and so on and so forth. And if you see in the meantime, you will see various numbers like 1, 2, 3, so on and so forth. If you actually go there, it designed that sentence or it curated that sentence based upon the information from this document. So you have something as with the rapid development of electronics and electrotypes. So there is such paper. So from there, it has picked this particular information. And also when it said this one, that means it is also coming from multiple sources. And there will be 27th source is here. So they made this statement of say, I'm developing something using the help of random forest. So that came from the 27th document. So on and so forth, you can actually chat with these documents cumulatively. So you can analyze the information more effectively. Because in a entrepreneur or a startup or a business, you will be flooded with the documents and you're supposed to dwell through those documents. And you might not have time because time is money many times. So whether certain particular information is available or not when you want to mine out or when you want to fish out. So at that point of time, these kind of packages will be helpful to you. And not only that, when you have a certain documents listed here, you can actually create a podcast also. So when it is created, I think you will not be able to hear it. It's okay. So actually, it creates a podcast of an discussion between two people. So it gives the summary of the complete documents to extend what it can do. Okay. So this way, you can actually speed up the process of understanding a document or reading of a document. Now, this is only till the document analysis or the interpretation of natural language process only. Now, if you want to deal with some other models like computer vision or natural language processing or any other thing, you have various models that are available, which will be released by Facebook, Google, Microsoft, and everybody. So if you want to know what are these various projects that are being run by Facebook, which is termed as Meta. So when you go to Meta Research, so in the previous session also they mentioned about something called as a computer vision based segmentation, right? So Meta Research, that is nothing but from Facebook, has released something called as segment anything. This model is like used to segment. Of course, it is a 2-year-old model, but it is a very good starting place. So you can actually segment anything, literally segment anything. You just drop an image and it's going to segment. And but sometimes if you want to only detect something, an object in an image, because you don't want to do a segmentation, but you want to detect, that is a bounding box. So that can be done with this. You can also do an silver set kind of a thing, that is getting the key points and connecting the key points. Okay. So Detectron is one package where when you want to do with the computer vision based thing. And this is a research that is open sourced by Facebook. And PACE, FAISS, people who are into natural language processing or large language models or RAGs, retrieval augmented generation, they will be knowing something about something called the vector database. So PACE is something which is being used for vector databases. And till this point, we spoke about only computer vision, but also if you want to use a sequence modeling kind of a thing, so FAIR, that is Facebook sequence modeling, can be also useful. So this is modeling of it's a modeling toolkit which allows the researchers and developers to train custom models for translation, summarization, language modeling, and so on and so forth. So when you have such huge models, so you need not to train from scratch. You can take the help of these models and you can build your tasks or your applications on top of it. Or you can use these models off the shelf. And similar things are available from Google also. So this is from Google research, semi-supervised semantic segmentation with vision language guidance. So if you see the GIFs here, it is evident that given any arbitrary image, it is able to segment those kind of objects. Okay. So these models are being available, and also you can explore other repositories from Google research. Along with that, there is NVIDIA. NVIDIA has an NGC catalog. Okay. So this catalog has various models that are readily available based upon tasks. It can be a computer vision task, it can be a natural language processing task, it can be a speech processing task, or it might be a recommendation task. Okay, so these models are very much available, and these are trained models. So you can use them off the shelf and get the performance of what industry is getting. So if you want to have a people semantic segmentation, so you want to semantically segment certain people. So this is that particular thing. So you can directly use this model. You not to retrain your model again. You can out of the shelf, you can take it, put it in your pipeline, and you're good to go. And you have TTS engines, and someone is speaking about face recognitions. You have also face detector, style GANs, GPU net, Tau brain, mask to former, earth to quadrip. So based upon your task in hand, you can actually, there is also face detection, face segmentation, point, speech synthesis. So TTS and TopNet is when you have it, some text in hand, you want to convert into speech, that is where the TTS will come into picture. So this way you have various models, right from segmentation to uh, detection to speech generation to natural language processing. So various models are very readily available. So it's up to you to use them. You can go through those models, pull those models, and these models are trained so you can get the performance of an industry grade. Okay. So this way, you can have the models which are straight away. Sometimes if you want to train, fine tune those models, or if you want to tweak those models, so you need to have those complete documentation or complete architecture of the models. So usually there is an website called as Hugging Face. So Hugging Face hosts all those models. So usually whichever is open source, they have these models which is readily available. You can pull them into your Python using a package called as transformers. So that will be helping you out to process your fine tuning your model, or rearranging your model, or for your task or for your language and anything. So Hugging Face is a place where it will be very much helpful for you when an existing model need to be fine tuned, or you want to change that model, rearticulate that model, and these things. So this way there is abundant space for AI models to be explored in entrepreneurship, and there is also space for those models can be customized for your application. Okay. So this way there are various models. So okay, no further tuning. It's okay. Let me use this one. Okay. So yeah, okay, finally we got that agent up and running. So the question I asked that agent for the web search is, what are the AI related news in January? So with the DuckDuckGo, what is it doing is it is looking for AI news AI January news. So I'm using an LLM to have various combinations of that query, and it is being pushed to the DuckDuckGo, and it's giving the information back. So upon getting that information from those websites, it will curate and collate that information and give me back. So let me do one. This is taking a lot of time. Let me change it to 3.2, 3.9. It's still running. Fine. Still running, it is searching. For some odd reason, should not be taking this much time. But it is taking this much time. Sorry. Maybe the stars are not aligned for me to give this presentation, proper presentation. Okay. Anyways, so this is the way how AI can help the people in entrepreneurship. But entrepreneurship is a bootstrapping of various tasks, and based upon the tasks in hand, you are supposed to pick your machine learning model, and accordingly also you have to pick your generative AI model.
So with this, I am open for discussion, and if you want to ask any questions or get an understanding of something also, it can be done.
If any queries are there, just you can ask. Otherwise, you can drop your queries in the drop box or chat box. Sir,
Sir.
sir, if it is local models, then how can they train, sir?
So if it is a local model, sir, in Python, I have shown Hugging Face, right? So
Yes,
from
sir.
Hugging Face, you can have this base model. So because you need those, usually when someone is inferencing those model, which are inference models, usually in 8-bit integers or something like that, right? So those weights will not be helpful for us. So at least they should be in a floating point 16. Those weights should be at least floating point 16, and the model architecture should be known. So for that, you have to go for Hugging Face. So from Hugging Face, you can get these models and you can tweak them as per your convenience. So you can fine tune them, you can retrain them, and so on and so forth from Hugging Face models.
You have shown us that Docker something, sir, Llama 3.2 or something like that. There we have
Llama
asked,
3.2. Llama
yes, sir.
3.2. Yeah.
How it was trained, sir?
So
That-
actually, Google initially started with Llama 3. Sorry, Meta WhatsApp has started with Llama 3.1, sir. So when it first time launched our WhatsApp thing, it came with Llama 3.1.
Yes, sir.
So when Llama 3.1 came, it is a huge model. Basic smallest model is an 8 billion parameter. The biggest one is more than 200 or 300 billion parameters. So it is being more costly for the company. So what they did was, if I have an web page of it, I will show you. So they have taken a student teacher approach, and they have created one small model. Give me 1 second. I'll try to pull out that particular.
Okay, sir.
I think this document is visible, right?
Yes, sir. Yes.
So this is how they have trained the 1 billion parameter and 3 billion parameter using pruning and distillation, sir. Yesterday I spoke about distillation approach, right? So here they have pre-trained model, and from that they have this Llama 3.1 billion parameter and 1 billion parameter and 8 billion parameter and 70 billion parameters, and using that they had this logic data, and from the logic data they had this 3.21 billion parameter and 3 billion parameter thing. So here you see Llama 3. Are you able to see, sir?
Yes, sir. Yes, sir. Yes, sir.
Llama
1.1.
3.2, Llama 1 billion and 3 billion. That was what was shown. So here they have taken this as a teacher approach, teachers, that Llama 3.1, and they have taken this 3.2 as the student, and they had this thing. So the basic idea is they want to deploy this 3.2 on edge devices, because edge devices can handle that 1 billion parameters or 3 billion parameters. So that is
Yes,
the
sir.
reason they have gone with this approach, sir. So this documentation is available. So
Okay.
the metadata open source. So you can, if you search this title, Llama 3.2 revolutionizing AGI and vision with open customizable models. So you
Yes,
can
yes.
take it. And also they can give in the document, how can you fine tune your own Llama model for your own task. That even that one is given.
Okay, let us let us conclude our sessions.
Okay.
Thank you so much, Dr. Sri Panikrishna sir, for that another excellent and insightful session, sir, on AI for business intelligence and decision making, sir. This being your third session in our FDP, sir, your commitment, depth of knowledge, and ability to deliver complex concepts with clarity that have given truly enriched learning, sir. Your sessions has provided immense value to all the participants. I hope so, definitely. And we deeply appreciate the time and effort you have dedicated to sharing your expertise, sir. Thank you once again, sir, for your valuable contribution to this program, sir. To our
Thank you,
participants,
sir.
I'd like to thank you all for your active engagement and enthusiasm throughout the day. This marks the conclusion of our second and final session of this day. But we still have 2 more exciting days of learning here. We look forward to your contribution and continued participation on day 5 and day 6. Have a great evening, everyone, and see you tomorrow. Thank you. Please try to provide us the feedback for this 2 days, this 2 sessions. Thank you, Ananda.